Thank you for joining our webinar today. Should your machine shop invest in fire suppression? I'm Susie Main and the person behind the scenes here. I'm FireTrace's Marketing Communication Manager, and I will go over a few housekeeping items before I get started and hand it over to Erin Haynes, our moderator for this afternoon. First off, everyone will be muted, but we do want to make this interactive. You may ask questions anytime during the discussion by entering them into the questions box. I will try to interject your questions throughout the webinar, and we will have plenty of time after the webinar to go over questions. However, if for some reason we are not able to get to all of your questions, we will get them answered and posted to our webinar recording page. Also, we are recording this webinar and we will supply you with a link to the recording and the slide deck, which will be sent to you within the next 24 hours. Also, if you have any technical issues, please send a message in the questions box or raise your hand and I will try to assist you. Now I will go ahead and hand it over to Erin.
Thanks, Susie. Good afternoon, everyone. I'm Erin Haynes, FireTrace's Senior Market Segment Manager for Machining, and I'll be the moderator for this discussion. I'll start off with some introductions, and then we'll take a dive into our discussion with our panel. So first off, we have Jamie Luke, Service and Applications Engineer for Millennium Machinery. Jamie joined Millennium Machinery with 23 years of manufacturing experience, including having a journeyman's for CNC machining and an associate's degree in advanced manufacturing technologies. Over the last 15 years, his focus and specialty has been with Citizen Swiss and Mayano CNC lathes. At Millennium, Jamie has worked cross-functionally as a service technician, a program transfer engineer, an applications engineer, and most recently being promoted to lead trainer. Congrats. Next, we have Mike Campo, one of our very own. He had just celebrated his 20th anniversary with FireTrace last week. He is the Central Regional Manager and Senior Key Accounts Manager for CNC and manufacturing applications. This man eats, sleeps, and dreams all things fire suppression, and that is a fact. To round out the panel, we have Jeff Gagnon. Jeff's the Vice President of Sales at Custom Service Solutions, aka CSS, based near Rochester, New York. Jeff works directly with customers each week to discuss their machine application, make a system recommendation, and provide support as needed. Since 2006, CSS has installed more than 4,500 FireTrace systems inside hundreds of different makes and models of CNC machines and grinders. Now that we've gotten through the introductions, let's dive into the first of our 6 questions with this panel. And Mike, if you wouldn't have a issue with kicking us off, why do fires start in machines?
Yeah, hi, Erin. Thanks everyone for joining. Yeah, by the way, that picture that you had of me that must have been taken. That must have been a high school picture. I mean, look at that thing, and then I aged quite a bit, I guess. But anyway, why do fires start in machines? Well, fires, for one thing, what you need to start a fire are heat, fuel, and oxygen. And if you look at a CNC application, it's pretty. You have that particular recipe. If first of all you have the oil, which would be the fuel, the heat would be generated from friction or a part that would ignite, and then oxygen. You mix those three and you get a fire. So what we are addressing when we're talking about fires in CNC machines is primarily an oil fire. And I know that there are, that a lot of people bring up the fact that they're, machining titanium or something, but if there's oil involved with the process, that is the main fuel that we address with these systems. So heat, fuel, and oxygen, you have what we call the fire triangle, and we're addressing primarily a Class B fire. You may have heard of the terminology ABC for fires. A is a fiber, wood, paper, things like that. B are flammable liquids, and C would be electrical. So we're kind of focusing on that, primarily addressing that with CNCs.
Awesome. Awesome. Thanks a lot, Mike.
Sure.
Jeff, one for you. What are fire risk factors that are commonly caused or commonly the cause of fires in machine shops?
Thanks, Aaron, and welcome to everybody that's listening in today. I guess we'll start off with this. If you ask people in just about any CNC machine shop that you've been to, if they've ever heard of a fire event, most people, if it didn't happen to them, or they may have heard of one, they will say yes. And certainly if they experienced it in person, they will be quick to share the details with you, and it's something that they probably never forgot. Fires do happen. You can look at the bottom of the slide and you'll see that approximately in the United States, 10 fires per week happen at machine shops. There are many different reasons that fires do start. One of the biggest reasons is operator error. And that is a full gamut of things that can happen there in terms of why that could be. Some of the things we've seen, people we've helped that had a fire, they didn't change the machine tools at the correct interval. So the machine tool got dull and either broke or just there was too much heat, too much friction, generated a spark and caused a fire. One time we had a person that decided to run the machine in manual mode just to check something or to test something, and they forgot to turn the coolant pump on, and they caused a fire. Also, actually had a customer one time tell me that there was too much mist and they couldn't see what was actually happening inside the machine, so they turned the coolant pump off temporarily just so they could get a better view, and as soon as they did that, too much heat and a fire happened. So many different reasons with operators, and this is why you'll often see a lot of fires happen actually during first or second shift when people are right near the machine, not always when machines are running unattended. Using oil-based coolants, obviously, is kind of a given. As Mike just said with Class B fires, the oil is what's going to catch on fire. Broken, misplaced, or dull tools, that kind of goes without saying. Those are probably the #1 cause besides operator error. This one may or may not surprise people. The first time running a new job, and that could be the first time running a new job on a different machine, or it could be the first time a company ever runs the job and gets a program or creates a program for a customer's part, and however it was made, they just needed to tweak the program so it doesn't cause a fire a second time around. So if you have a fire suppression system before you run a job for the first time, you're likely to have better results and you're protected if something were to happen. Changing a grade or a brand of bar stock, this is one that we've seen recently in the last year. We have a company near Rochester, New York, that they had a same supplier for several years, and last summer they switched. They have approximately 20 Swiss CNC machines, and they've had 8 fires since last June. So that's quite a bit of fires for that small number of machines. And all of those fires happened after they changed the bar stock supplier. Some companies retrofit machines and actually add a high pressure coolant system, and if that can generate some serious mist that may not have been in the machine prior to. So that's another reason. Too much oil mist in the machine, that could be because of a broken or clogged mist collector, addition of a high pressure coolant mist system, or the filters on the mist collector just they're clogged, they need to be changed, or the mist collector needs to be serviced. High-speed spindles, today's machines are faster and faster and can produce more parts per hour. With that comes the added risk, of course, of the potential for there to be a fire. And then I'll end with operator error again. Every July, vacation time, we have a couple 3 shops that are we know we're gonna get a call. The primary operator is out for a week or two, and they have newer associates replacing them that may not be as familiar with the machine, or may not replace the tools as often, or something like that. Could be people in training. Really no fault of the operator specifically, but it is the root cause of why that fire did happen. So these are some of the things that we've seen. And Jamie, you could probably speak to some things that you may have seen as well.
Yeah, thanks, Jeff. Yeah, I 100% agree with everything Jeff said. I mean, I think our number one issue is operator error. If it's a new operator, old operator, coolant, they didn't fill the coolant, they didn't clean the chip basket, or the tool didn't get replaced in time. We've seen in our world, we see a lot, because I'd say 99% of our machines, we put a high pressure coolant on it, and that just causes mist. And then if you got a dull tool with that little bit of mist, and you run in titanium that sparks real easy, it's a solution for a fire. I mean, it's going to happen. And then, yeah, I mean, pretty much just everything Jeff said is right on the money.
Yeah. Awesome. Thanks, Jeff and Jamie. And then what you see is it's a lot of everyday things are risk factors. So well said. Thanks. Jamie, give this one to you. What are the different types of fire protection options?
So you got your standard fire extinguisher, which is usually mounted on a wall somewhere. It could be 20 to 50 feet away from any given machine at any time. You have your sprinklers that majority of facilities have, which is, I mean, you imagine if the height of your ceiling, you got a sprinkler that's 20, 30 feet up in the air, it may take a machine fire, it might take 30, 40 minutes for that sprinkler to go off, and then you're just flooding your whole system. Then you got a fire trace system, which I would say a fire inside one of our machines, that fire trace would go off within 4 to 5 seconds, and you got minimal damage that way. And actually at my last employer, we had a fire without fire trace, and an operator had just changed the bar. He was running cobalt chrome, and he did a cutoff and then turned his back, and as it did a cutoff, a hot chip went into the chip pan, and within 2 seconds the machine went up in flames. He ran and got a fire extinguisher. Within 5 minutes, 10 minutes, he had it put out, but they emptied 3 fire extinguishers inside that machine, and then we had to vacate a good 30, 40 employees outside for half hour, 30 minutes, half hour, an hour, just to let the smoke clear. And then that machine was down for a month to 2 months between the cleaning of the fire extinguisher, all the powder, all the electrical components had to be replaced, bearings, linear guides had to be replaced because of the powder. So there's just an amount of damage with a manual extinguisher like that. And then I think Mike can talk a little bit more about the fire trace system itself.
Yeah, that's one of the things when you were explaining the response without any automatic system. Most commonly, the extinguishers that are in a shop, they should be some type of chemical that's not going to be damaging to the machine. And if you grab a dry chemical powder extinguisher, we recall an incident where we had that happen with a company where they had a fire in a pretty substantial machine, something like a Williman, where very high price machine, precision machine, and they dump a 20-pound dry chemical suppression or dry chemical portable extinguisher in it, and fires out, like Jamie said, but that machine is going to be down for an extended period of time, and that is due to the cleanup. And that when you get that powder material in there, that is definitely detrimental to what you're trying to do. You want to when you have a fire, you want to make sure that it's suppressed quickly, but also with minimal collateral damage to the machine itself and anything around it.
Well put. Well put. Thanks, Mike. Piggybacking off of the fire suppression system topic, what are the best suppression agents to use?
Yeah, that's, I might as well, kind of dive into this, since from a fire protection standpoint, I want to stress that when we were talking about what would happen if you used a powder extinguisher in a machine, same thing with when we design these systems to protect CNC machines, we want to make sure that the agent is going to be fast reacting and also very clean. So the ones that we make available and that are extremely effective are FM200, which is a DuPont Chemours product, 3M Novec, and carbon dioxide. The first two that I mentioned, FM200 and Novec 1230, unique about those, they're considered clean agents. If you will, they're like a concentrated fire suppressant. And if you go back to that, or if you recall, that original fire triangle we discussed in the first slide or two, that is, the three elements, heat, fuel, and oxygen. And what we're doing with the first two, FM200 and Novec, we are chemically suppressing a fire. So we're introducing this agent, this chemical, into the volume, the machining volume. And what it does is it disrupts the chain reaction between primarily the oxygen and the heat and fuel. So you kind of put this block in there, and it disrupts that that process, and the fire, boom, goes out instantly. CO2, another clean type agent, and it primarily is a mechanical suppressant. And when it's discharged into the machine, it has a cooling effect, so it reacts to the heat, but also it is an oxygen deprivation mechanical suppressant. So it will displace oxygen, and also the fire goes out. But the key about all three of these agents are they're clean. So you don't have any damage to the oils that are used. And if I recall, Jamie, what were you? We talked about this in the past, but that oil can be pretty expensive, if I recall.
Yeah, so our typical machine, it's going to take 55 to probably 65 gallons of oil. And I actually checked with our supplier, our drum of oil is between 1,200 to 1,400 a drum. So, I mean, you could have anywhere from 1,200 to probably 2,000 in lost oil just by not using the clean agent. And I've seen multiple fires in this situation, and we use, I'd say 90%, we use Novec, and it literally changes nothing in your oil when that tank goes off. And really what I remember, this has probably been 5-6 years ago when I first met Mike, he brought in a little sample of it and he poured it on a bunch of papers on my desk, and it just disappears. It doesn't leave any trace on your papers at all. And to me, that maybe a simple mind, but I just thought that was awesome. I mean, I don't know. It's something, I think it's a neat thing.
It is awesome. And it's one of the things, we get asked quite often when we try to explain that the suppressant is not going to leave any residue whatsoever inside the machining volume, none whatsoever. So that being very critical. So no matter what oil you're using, it does not contaminate that. And also the fact that you put that fire out as quick as possible to make sure that it gives you the opportunity to get back up and running in a short period of time.
Awesome. Awesome. I'm learning so much. I appreciate it. Moving on. So Jamie, I'm gonna ask you this one. What added benefits do machine shops get by adding fire suppression?
So I would say, once again, I like percentage. I'd say 75 to 90% of our machine sales, we install a fire trace on it. And I would say majority of our customers run their machines unattended. And we always stress it's almost mandatory to install a fire trace to run unattended. Because if you had one fire on an unattended machine and the building was empty, I don't know, it don't matter if you have 2 machines or if you have 10 machines, you lose that one machine and you have the ability to lose all your machines in your building itself. I mean, you're going to lose everything you've built. So, I mean, with that, I mean, you lose one machine, you got a chance to lose your contracts, which, I mean, a lot of people, I think Jeff said the other day that a lot of customers he deals with, some of the people with their contracts are making them put fire trace on their machines as a stipulation on the contract, which is pretty interesting. And you got the chance to have a reduced cash flow as far as your insurance payout. So if you have a machine that goes up in flames and you're waiting on insurance, it could take an insurance company 3 to 6 months to decide if they're going to pay you out on that. In the meantime, you're down another machine and you need to get up and going right away. And then I would think the major thing is your downtime for repairs. Like I said before, that one machine we did, it was down for 1 to 2 months just on repairs. And if with a fire trace system, you don't have that. You have an hour, 2, 3 hours at the most that you may be down. And of course, it protects your shop's personnel. I mean, if someone was standing there when the fire happened and the door was open by chance, I mean, you could get burnt and all that. And then there's also your insurance rate reductions. I don't know if Jeff's got anything to add to this.
Yeah, no, those are definitely good points. And I think that the number one was it allows you to safely run unattended. And honestly, in a lot of cases, companies can generate revenue by running unattended. So it's kind of an opportunity, if you will, to expand business, and or accept contracts that you might not have had the machine time for otherwise. If you look at the slide in front of you, this is just kind of a rough idea of what losing a machine can cost you. And again, this would just taking a rough figure of an average CNC machine being around $250,000. 4 to 8 weeks average downtime if a machine is lost. The fastest I've ever seen a machine get replaced, it happened to be in Connecticut, was within 1 week. That just was, the customer got lucky and the machine tool provider had another machine just like it on the floor and they were able to get it over to them. Most of the time it takes all of 6 or 8 weeks at least to get a new machine put into the facility where the fire happened if the machine completely is a complete loss. So if you look at the downtime for shift, assuming 3 shifts per day, your cost per week can be very expensive. And this one fire in one machine can end up costing you, into the millions of dollars. So definitely something that's not fun for anybody that has to deal with it. I would say the other things I've seen firsthand with customers is the frustration factor in dealing with the insurance company is very high. The payouts I've seen when the customer finally gets the insurance money is usually 6 to 8 months or even longer. In almost all cases I've seen, the company has to buy or lease a new machine immediately out of pocket or through some creative financing, well before they're reimbursed by their insurance company. And they would have to do that in order to meet the production contracts which they have. So most companies don't have an option to suddenly lose a machine, or worse, more than one machine. So really, in summary, adding fire trace and avoiding that, you can avoid a catastrophic event, and you really can turn a fire into a maintenance event with very little downtime.
Yeah, that perspective is fantastic. Sounds like a fire suppression system is worth its weight in gold.
Yeah, and I think, yeah, I was just going to say one quick comment that even I think Jamie and Jeff both alluded to this in some of their comments earlier, but you know, investing, there are companies that if they're going to get a contract, it's a nice thing to have on your resume that, hey, you know, our machines are also, by the way, we have fire protection on all of our machines, which is you know, something that in many cases your customers are going to obviously put that into the decision-making process. Like, hey, we're going to go with this company since they've got a contingency plan for any problems that might flare up. So it's a sell point actually for being able to maintain a continuous operation.
Absolutely, absolutely. I appreciate that, fellas. So Jeff, can you educate us on the installation process?
Yeah, sure, Aaron. So the inside of every CNC machine and grinder is a little bit different, but there are things that we do consistently in every single installation. It generally is going to take about 3 to 5 hours per machine. I've seen machines where we were there for 6 or 7 hours for one machine. It just depends on what the layout inside the machine looks like. One thing that we will always do is run the fire trace detection tubing throughout the machine and across the mist collector opening. And this is very important. I would say at least 95% of all the fires we catch run across the mist, are detected at the mist collector opening. And that's because that's where the airflow is going. It's going to pull the fire generally in that direction. That's where the most heat is going to be, and it's going to activate the tubing in that spot. We always, 100% of the time, without exception, electrically connect the fire trace control box to the e-stop of the machine and the mist collector. And what that means is, in the event of a discharge, if a fire is detected, it will be extinguished, but we're also going to e-stop the machine, and we're going to e-stop the mist collector. And that is going to prevent the chance for the fire to reignite again a second time. We will also ask the operator, after we've done installing, to cycle through all of the moving pieces inside the machine to make sure that where we place the tubing and the distribution piping and the nozzles are not interfering with anything during the machining process. It's rare, but every once in a while we'll be in that test phase and we're like, okay, we got to make a slight adjustment, and it's a good thing we took that step, and then going forward, they're all set. We always install a manual release right near the control panel of the machine. Fire trace systems are automatically activated, but they also do have a manual release in the event that an operator was fast enough to get to it and activate the system. And lastly, before we leave, we would test the fire trace system, and then we would ask the operator to resume production of parts. We want to make sure that we see that machine making parts for a good 15 or 20 minutes before we leave, just to make sure everything is 100% just the way it was before we arrived.
That's fantastic. That's fantastic. I'm sure your customers appreciate it. Well, I want to thank you, Jamie, Mike, and Jeff, for all those great insights. Let's see if we have any questions from the audience.
Yes, we've had quite a few come in. So let me start with the first one is what happens after a fire in a machine that is protected by fire suppression? Sort of guess what are the steps, what needs to be done? Maybe elaborate on how long the downtime is.
I can jump in this for our customers. I know, and every customer is a little different, but in a general downtime situation, we're between 1 to 2 hours maybe. So we wire our system in where we tie it just like Jeff in the e-stop or the auto power off circuit. But we also make it so if the fire trace does go off, we can reconnect it normally. The machine can operate at risk until we can be on site to fix it. Or if maybe that we didn't have a spare tank, which we normally stock spare tanks here. But so basically, if you had a fire go off, you're gonna need your tank recharged. And then the red tubing is what usually causes that. And there's usually a split in it. So basically Fire Trace has butt connectors that you just cut the bad piece out, put a butt connector in there, and then recharge the system. And then I like to stay there for a half hour to an hour and make sure that system doesn't slowly leak and have a false discharge. And I don't think I've ever ran into that issue, but just as a safety feature we do. And we also have some customers some medical companies that would rather just replace the whole red line, which isn't still not a big issue. It's just running it back through the machine. But I would say our typical downtime is 1 to 2 hours. And I don't know what Jeff's seen on his side.
Yeah, it's an interesting question because it really depends where the customer is located in relation to where we are. But generally speaking, the machine will be e-stopped. The company needs to identify the root cause of the fire, make sure that before they would resume any type of production that they fixed the root cause, figured out what it was and fixed it. If we're nearby, or usually if they have a spare cylinder, if we're nearby, or if their personnel are trained to recharge the system, we have customers that have downtime of 1 to 2 hours. Where other customers may be 2 or 3 states away from us, that we may be there the very next day and get them up and running again. It just depends on the situation. But we would arrive with a full cylinder, take away the empty, put the full, replace the tubing, test it, and again, make sure that customer resumes production and stay there for a little bit, just like Jamie suggested. And so really just turn it into a maintenance task rather than a big fire event that you have to evacuate your building or something like that.
Yeah, and to kind of add on that, I don't know with the Fire Trace system if I've ever seen actual machine damage. I mean, you're not getting into replacing anything on the machine. It's just the Fire Trace itself.
Yeah, exactly. I mean, we're just a Fire Trace distributor, so we've never fixed anything in any of the machines we recharge. We average about 2 machine saves per week with a customer base of about 4,500 currently. And we don't have to fix anything inside the machine, just fix the Fire Trace tubing and recharge the system.
Great. Actually, that's probably a good segue into the next question on what percentage of customers choose to install Fire Trace when purchasing a new machine. I think probably hand that one off to Jamie, and then Jeff, you can follow up with what you see in your line of business as well.
Yeah, I mean, I know when we quote a new machine, it's just our standard practice, put Fire Trace on it, and then the customer decides yes or no. But I would say 90% of our customers have Fire Trace. And I would say I've been with the company for almost 6 years, and I think I've seen 3 companies that have had a fire and have lost a machine, and then those 3 companies proceed to add Fire Trace to the other 10 to 15 machines they have. And then, I mean, we do a lot of medical companies, and I would say 99% of those all have Fire Trace on their machines. So it's just a standard option that we put on every one of our machines going out the door.
Yeah, I would agree with Jamie. Most of our existing Fire Trace customers that we've had for 10 or more years, it's every single machine they buy that's new. It doesn't matter what make or model it is. They will contact us and have us come in and add fire suppression usually right in the very beginning before they even run the machine. Once a company usually adopts Fire Trace, and once they've had 1 or 2 fires or 1 or 2 machine saves, they usually won't take a chance, and they would like to have all the machines in the building protected.
Great, thank you both. So here's another interesting question. Can a Fire Trace system be removed from one machine and installed into another machine?
I could take that one if you like. The answer is yes. I'd say the vast majority, probably 98% of our customer base, would rather sell the older machine or trade it in with the fire trace system, leave it installed, if you will, and then just have a brand new system installed when they get the new machine. But you can, it is, if you make the investment in a fire trace system, it can be removed from an old machine, and we can install it in a subsequent different or new machine for you. Nearly all of the components can be reused. The fire trace detection tubing cannot be reused, and the distribution piping usually needs to be reconfigured. But the majority of the investment of the fire trace system, absolutely, you could. We do have some customers that we've probably taken one system from 10 years ago and it's on their third machine. So it is something that can be done.
Okay, great. This one goes back to different types of fire protection options. One person has asked, does it make sense for a sprinkler in a building to have that, but exclude in areas of high value stock and equipment so they're not damaged by water?
Let me address this, or see if I answer it correctly. I guess if I understand the question, is it possible to have the building sprinkled, but then remove the sprinklers in the area where the high value equipment would be located? Is that pretty much the understanding? If that is the case, the sprinklers are structural protection. They don't care what is in the building. So you have a structure, and in a lot of cases, those systems are mandated by state fire laws and codes. You have to sprinkle the building. So with that in place, it's strictly looking at the structure. So you could have whatever inside, but if you want to protect a particular valuable piece of equipment like a CNC machine, by putting fire trace on there, the risk of that sprinkler head building sprinkler actuating is severely reduced, because you're putting the fire out before it has a chance to get out of that enclosure and rupture the structural building sprinkler head. Sprinklers in general. I know of one incident where we had a company that had a large number of fire trace systems on machines in an area, and I guess got a new machine, and we're running it through some test cycles to get it going, and they happen to have a fire in it, and the fire actually actuated the sprinklers, and the collateral damage around the area disrupted that section operation, just because there was nothing to address the fire, and it was able to actuate the sprinkler system. So yeah, it's pretty difficult to get something like that removed, because because of the codes and the laws. But putting something like this into suppress before it has a chance to get out of the enclosure and rupture a sprinkler head is definitely a good option.
Great, thank you. One of the other questions that we have is, what are the most common misconceptions related to fire suppression and CNC applications? And I'll just toss that one out to the group.
Misconceptions.
Or maybe roadblocks that you experience talking about it?
I think in some cases there's a lot of concern about, okay, if we put this in, is there going to be powder? What's going to happen? Sometimes is there going to be residue? Things like that. I think that's one that I've heard quite often. That's when I had that explanation, and when we were discussing agents, the clean agents really, and even Jamie made the comment with the Novec product as well as FM200. Novec, by the way, is a fluid. FM200 is a gas. Those were those two chemical ones that I explained earlier. But Novec, you have to force it to become a gas, and FM200 wants to be a gas. So they're different in that manner. But they, like I said, they're both are extremely clean. There are some other chemicals out there that can be used, and I've seen them used in some machines, and they claim that they're clean agents, and they have a little bit of dry chemical powder in them, and a combination of that with some of these clean agent gases, minimal residue, but there is residue. You can wipe your hand and there's actually a powder, and that gets in the oil and things like that. I don't know if I answered that question totally, or if anyone else has any other misconceptions that come about with some of the systems, but that's one that I could think of just offhand.
That's actually the only one that I thought of. One is that there really aren't that many questions that I receive about the systems themselves, except for, will it harm my machine tool oil? And we've covered that thoroughly today, that it, obviously will not.
Okay, great. I know we're trying to keep this to the 45-minute mark, so I'm going to try to push out a couple of more questions. This one is, what factors should be considered when choosing to use a fire suppression system for your CNC machine? There's sort of a good guide or a good checklist to go by? And again, I'll throw it out to the group.
The question, it depends, I guess, whether if this is for a customer that's never had fire suppression before, which I have conversations with this type of customer often. I would say if customers are cutting with stainless steel, titanium, if they've got high pressure coolant and they're cooling with oil, and especially if they want to do any type of unattended running, the answer would be you should absolutely consider it. And we've done things for customers where we could, if they have 10 machines, we could phase in 1 or 2 installations per month over the course of a year to get them protected, to spread out the investment cost of that. But really, if people are running 3 shifts a day, making a whole bunch of parts, it just becomes a very obvious choice. That's something that you should consider, I would say.
Okay, great. Well, we'll get one more quick question in here. How often is there malfunctions with fire trace systems, and what is done after a malfunction?
I would say in our experience, the only malfunction you may ever have is the line accidentally getting pinched or cut. And I would say it's less than a 5% chance of that happening after the install. Just kind of like Jeff said, we cycle through the machine, move all the axes, make sure nothing's going to get pinched. The only time where I see something that could happen is if an operator moved a line that shouldn't have been moved, or accidentally nicked it with a tool somehow. But I can only think of, in the 5-6 years I've been doing it, 2 or 3 instances where that might have happened.
I would agree. A false discharge on the fire trace system isn't something that happens very often at all. The nice thing about a fire trace system is it's a pneumatically based system. So you have a pressure gauge on the fire trace cylinder and you have a pressure gauge on the manual release. And every single customer that I speak with, whether it's the first time I talk with them or when doing an annual inspection or just talking with people in the shop, is just please look at those gauges every single day. That should be part of the machine operator's checklist at least once a week, but preferably once a day. And if they ever see the needle going down on the fire trace gauge, just pick up the phone and give us a call. Next time our technicians nearby will stop in and just see if there might happen to be a real small leak. But it's a very, very small percentage of people that this ever happens to. Most of the systems, you install them properly and they're good to go for a very, very long time.
And kind of add on to what Jeff was saying there. So the system itself won't go off unless there's a puncture in the line. If it's got a small leak and you gradually see it going down, you're not going to discharge your tank. You're just going to lose your pressure there. So if you notice it go down, then yeah, you call right away and we can catch it before the tank goes off.
Yep.
Okay, great. Well, it looks like we're just over the 45-minute mark, so we'll go ahead and get it wrapped up, which I'll hand back over to Aaron to do. But again, we did have a couple of questions we weren't able to address, but we'll make sure that we reach out and get those answered for you. And then Aaron, I'll hand it back over to you.
Awesome. Thanks, Susie. Yeah, we just want to thank our panel again. We appreciate your time. Also want to thank Xometry for co-sponsoring this roundtable discussion. Finally, a special thank you for everyone that joined us today. We definitely hope that you found this discussion valuable. Again, we will be sending out a recording of the slide deck within the next 24 hours. Also, stay tuned for a Xometry webinar next month on how to grow your manufacturing business and improve cash flow. Xometry will demonstrate how you can connect to their continuous stream of job opportunities and simplify your AR process. But in the meantime, stay safe. Thanks a lot and goodbye.
Perfect. Bye, guys.
Thanks.